Hello there, Mr. Sutton here, bringing you this lesson on right triangle trigonometry. Specifically, we are going to use sine, cosine, and tangent, the trig functions, to find sides and angles of right triangles. For the warm-up on this one, take a moment to take out your graphing calculator and plug sine of 30 into your calculator. All right, let's see how that worked out. Now, if you got 0.5, then you're in the right mode. But now let me plug it into my calculator here. So here's my calculator. Here's the sine button, and I'm doing, they said, sine of 30. And I'll close the parentheses. Enter. Oh, that is not 0.5. What could have happened here? If you got that crazy decimal that I just got, you need to change your calculator's angle mode from radians to degrees. Let me show you that on my calculator. So here's the mode button next to the second button. And if you go to mode, you'll see there's an option for radians versus degrees. We'll go down to degrees and change it, and then quit back out and try my input again. Let me just go back here and grab that same input. And now if I press enter in degrees mode, I get 0.5. So make sure you've got that change made from radians to degrees, and then try out the following two problems. All right, now if you've done these correctly, cosine of 40 should have come out to about 0.7660. And tan of 82 should have come out to about 7.1154. Let me show you on my calculator again, just to show that I'm not trying to pull a fast one on you. So cosine of 40, there's that decimal I promised. And then here's the tan button, tan of 82, gives me the 7.11 and change that I promised here. All right, so that's great. So what did we just do? Right? I mean, we pressed some buttons on our calculator, but sine, cosine, and tangent, what do these all mean? So these functions are trig functions. These are triangle-based functions. The full function is y equals sine of theta, cosine of theta, tan of theta, or you could say f of an angle. What's basically happening here is our input, this weird theta symbol, this is just an angle. We're taking an angle into these functions. And then what are we getting back? What we are getting back is the ratio between two sides of a right triangle that has the angle that you just plugged in. So you might remember with 30, 60, 90 triangles and 45, 45, 90 triangles, they all had their own special ratios. But it turns out every right triangle has special ratios. And these sine, cosine, and tangent functions are going to give us access to those special ratios. Each of those trig functions we just saw is defined using 2 out of 3 of our special triangle side names. Here are the 3 names. The first one you already know, the hypotenuse, or hyp for short. That's the side across from the right angle. So we've got this side or this side. Doesn't really matter because we can always pick out the right angle. We can always find the hypotenuse. Now the other 2 side names are based on where your angle is in the specific triangle. So one of those sides, the opposite side, or op for short, we define that as the side across from or just not part of the angle that's in your problem. So if you look at this first triangle, this angle in the lower right, the opposite side is across from that angle, so it happens to be the left side of this triangle. It's not one of the 2 legs that make up this angle. But over in this other triangle where your angle is up here, now the opposite side is across from this angle, which means it's down at the bottom of this triangle, not on the left side. So you always have to look at your angle and look across from that to find the opposite side. Finally, the adjacent side, or ADJ for short, this is the side that's touching the angle. In other words, it's one of the legs, but it's not already the hypotenuse, because the hypotenuse is always going to be touching one of these 2 non-right angles. So that other side that is part of that angle is the adjacent side. So down here in this triangle, up here, this is the side that's touching but not the hypotenuse. So we're going to use different combinations of these 3 sides to define our 3 trig functions. Using those different side definitions, let's now define our 3 functions, sine, cosine, and tangent. So sine, we define the sine of an angle to be the opposite side over the hypotenuse. Whatever decimal that comes out to, that's what our calculator gives us when we plug in whatever angle this is to the sine function. Cosine of an angle is going to be the adjacent side to that angle divided by the hypotenuse. And tangent of an angle is going to be the opposite side over the adjacent side based off of that angle. So these are 3 different formulas, but there's a nice little mnemonic for memorizing all 3 of them, and it is this SOHCAHTOA mnemonic. So we have sine, that's SOH, or so, and then cosine equals adjacent over hypotenuse, that's ca, and then tangent, that's tan, equals opposite over adjacent, so that's toa. So SOHCAHTOA, if you write this out whenever you're doing a right triangle trig problem, you can usually find the answer. Now you have to note that these relationships only work with right triangles. If you have a non-right triangle, you're going to have to use something else, but this at least gives us a starting point. So for this problem, given the triangle below, we want to write the correct ratios for each of these trig functions using our SOHCAHTOA definitions that we just talked about. We'll do the first one together, and then I'll let you try the other ones. So let's say we're trying to find sine of A. So I look at my angle A, and now sine we saw was opposite over hypotenuse, so sine of A would then be the opposite side, 12, over the hypotenuse, which is always just going to be 20 for this triangle. So 12 over 20. All right, pause the video and try the rest of them out. Okay, let's look at cosine of A. That's adjacent over hypotenuse. So looking at angle A again, the adjacent side is 16, hypotenuse is 20. And then tangent of A, that's opposite, which is 12, over adjacent of 16. Let's shift to angle B now. With angle B, sine, that's opposite over hypotenuse again. Opposite this time from angle B is 16. Hypotenuse is still 20 though, notice. Cosine of B, we've got adjacent 12 over hypotenuse of 20. And then finally, tan of B, that's going to be opposite of 16 over adjacent of 12. So at this point, we're actually going to use our SOHCAHTOA functions to figure out some missing sides and angles of right triangles. So here's a triangle where we're given a side of 10, a side that we're looking for that we'll call x, and this 27 degrees. The key on these is you want to choose the function that has the side that you already have, like this 10 side, and the side that you're looking for, like this x side, in the ratio. So I would write out SOHCAHTOA when you do these problems, and then pause the video and see if you can figure out which of our three functions to use here. All right, so looking at the sides that we have the hypotenuse for sure. That's always the easiest one to pick out. So we're either going with SO or CA because they both have H. And then this 10 side, is this opposite or adjacent from 27? Well, it's across from 27, so this is the opposite side. So we need opposite and hypotenuse. That's so. So we're using sine. Let me just write out that formula now. Sine of theta equals opposite over hypotenuse. And at this point, we're just going to plug in the information we have and solve for the information we don't have. So theta in this case is 27. The opposite is 10. And the hypotenuse is this x side. And now we're going to go ahead and solve. So we need to first get this x out of the denominator. I can do that by multiplying both sides by x. So I'll have x sine of 27 degrees equals 10. But then I need to get x by itself, so now I need to turn around and divide by sine of 27. And at this point, it's the calculator's job to give me the answer here. So I end up with 10 divided by sine of 27, which comes out to 22.0 if we round off to the nearest tenth. So that's the basic idea of how these are done. Now, one little trick, if you find yourself in this situation where a trig function equals a number over x, it turns out if you look at what we did to get from here down to here, you really can just switch the x and whatever's up here. I call it the old switcheroo. Just switch them, and that ends up taking the place of multiplying and then dividing. Here's another right triangle for you to solve. Pause the video and see if you can find x. All right, so SOHCAHTOA is our go-to method on this, again, because we have a right triangle. And which function are we using out of this? Well, we are looking for the opposite side, and they gave us the adjacent side. They did not give us the hypotenuse, so that means we have to go with TOA. So tan equals opposite over adjacent. Putting in our information, we have tan of our angle, 47, equals, we said the opposite side was x, the adjacent side was 98, so x over 98. Solving for x, we can do that by just multiplying both sides by 98. So x is going to be 98 times the tangent of 47. Time for the calculator now. So I'm plugging in 98 times tangent of 47. Comes out to 105.1 if I round that off. For this next example, we're still trying to find a missing variable to the nearest tenth, but how is this different from the ones we did before? Well, you might have noticed that now we are looking for an angle, not a side. So in situations like this, we need to set up a trig ratio that has the two known sides. So this time around, we're going to know both sides, and it's the angle we'll be solving for. Pause the video and see if you can figure out which trig ratio to use here. So since the two sides we know are not the hypotenuse, we have the opposite, we have the adjacent, we're going with TOA, or tangent, equals opposite over adjacent. So plugging stuff in here, we have tangent of x, because that's our angle, equals the opposite side of 9 over the adjacent side of 12. And to solve for the angle this time, to get rid of tangent, we need to use inverse trig functions, and I'll show you those on the calculator in a sec, but we basically need to do tan inverse of both sides. So what this looks like is we have x equals tan inverse of 9 over 12, tan with a little -1. Now I have to emphasize that this is not the reciprocal of tangent. That's something else we'll see later on in this chapter. This is basically a function that undoes whatever tangent does. So tangent takes an angle and gives you the ratio of the opposite and the adjacent sides. Inverse tangent takes that ratio and gives you back the missing angle. So how do we do this on the calculator? On our calculator, if you look at the sine, cosine, and tan buttons, right above them you'll see these little sine, cosine, and tans with the little -1s. Those are the inverse functions. To get to those, you have to do second and then the trig function. So let me show you that on the calculator now. So I'm going to do second, and then I wanted second tangent for this problem, so second tan. That gives me tan inverse. And now I want to take the inverse tan of, we said 9 over 12, so 9 divided by 12, and equals, we said 36.9, so that is the actual angle in this triangle. Pretty cool. We'll do one more of these types of problems. Try this next example on your own. All right, let's see which trig function you went with. So we have the hypotenuse here. We can quickly identify that across from the right angle. But now we have to figure out what this 7 side is. Since this 7 side is the other leg of the angle, it's touching the angle and it's not the hypotenuse, this is the adjacent side. So that means we have cosine equals adjacent over hypotenuse. So then we've got cosine of x equals our adjacent side of 7 over the hypotenuse of 10. And we have to inverse cosine 7 over 10 now. Now, if you got this upside down and you did 10 over 7, your calculator is actually going to give you an error, and we'll see later on why that is, but there's a nice little error checking thing thrown in there. That also happens with sine if you have things upside down. Tangent, if you have things upside down, the calculator still gives you an answer. But at least with sine and cosine, if you're finding an angle, you'll know that you did something wrong. But here, we want 7 over 10, so let's do that now. So we've got second cosine, and then 7 divided by 10 equals 45.6 degrees. So that's it for this one. Until next time, Mr. Sutton signing off.